Okay, everyone. So this is another video that I'm going to talk about on proving some similarity relations in triangles. And I guess this is one of the most challenging ones. So which is I highly recommend you to pay close attention to each statements I will make and convince yourself before you move on. If you are not satisfied with some of the explanation, please don't move on before you actually slowly think about what I said and make some sort of connection of what we learned and see if that makes sense. And if that makes sense, just move on after that, okay? So what we are trying to do is if the line divides two sides of a triangle proportionally, okay, and then it is going to be parallel to the third side. So what does that look like? So let me try to kind of give an example of what they are trying to ask. So they are telling us if the ratio of FH, let's say this is 2, this is 4. So the ratio of FH to HD is 2 to 4. So this is 2 and 4. And the ratio of EG to GD has to be same. So let's assume this is 3. So that means this is going to be 6. Okay. Again, these are just some numbers to make a bit visual, but it doesn't have to be 1 to 2. It could be any ratio. So, but the overall idea, it just says if the ratio, let's say this is 2 and like 5, for example, if this is 2 and this is 5, maybe this is like 4 and this is 10 and stuff like that. So the ratio will be the same. If you are told the ratios are equal, then we are going to use that proportionality to prove that this line and this line is parallel. That's the goal, okay? So to do so, we should start with the given information, which is already given right here. FH divided by HD is EG divided by GD. That's given. That's the first statement that we have. That's the only information actually was given. What we could do, FH, FH is this guy, okay, and then DH is right here. So this may be not the first time that you've seen before, but you may add 1 to each side of the equation, right? And then you will see why I'm doing this in the next steps. So if you add 1 to each side of the equation, right, FH divided by HD plus 1, and then I add 1 to both sides from the first statement. So there is, if you want to explain what happened here, so from the first step to second step, then you can just say you add something to both sides. So let's see if there's any good relation. I guess that would be addition and subtraction properties. So we just add 1 to both sides of the equation. So if you are wondering why, so you will discover in the next step. And the next one says FH divided by HD, which is the first fraction, nothing changed. But instead of 1, we can write HD divided by HD, so we can actually get the common denominator. Just imagine this is a fraction like 2 over 5. Then you can write plus 5 over 5, which would be something like that. So we just add this fraction to this number, which is 1. But the reason why we are writing 1 as HD over HD, because we have the common denominator now. And the same thing going on the right side. So instead of 1, we can just write GD divided by GD, because that's the denominator of this fraction. So if you do so, since we have the common denominator, we can add FH and HD as numerator. So, but denominator can be written only once, which is HD. Okay, so that is something. And same thing with the other side. So EG and GD divided by GD. That's the just adding the numerator. That's what we have. Okay, so let's continue what we have next. So now we have FD as the fifth statement. So FD is this whole segment, right? The larger triangle is equal to HF plus DH. So FH and plus HD is equal to FD, which is we call angle segment, I would say addition. So not angle, actually, segment addition. So let me see if we have something nicer. Yeah, it's called segment addition property. So we add 2 pieces, HF and DH, to get DF, basically. And the same thing with ED. So ED is just the longer side right here. So that's equal to GE and GD. So that is right here. So that's also angle segment addition property. Not angle, but so that would be segment addition property. Okay. So, but let's think about what's going on so far. So what we did was we just write we added 1 to both sides. Now we just replace with 1 with this fraction, and then we add the numerators to get simplified. But since adding 2 segments wasn't fun, so we just write those sum as FD equals this one, AD as these two. And now we are going to replace FD with this numerator, because FH plus HD is FD. So we are going to replace that. And EG plus GD is equal to like AD. So we are going to replace the numerator with that. So what happened, right here, this guy is same as FT, which is why it just changed, which is we call substitution. So for the second one, ED was equal to these two, which was my numerator right here. So that has to be ED. So I hope that makes sense. Again, if you don't get this yet, so please stop and think about what happened and see if that makes sense. So now we saw that FD, so let's look at the picture. FD is this whole segment, right? And divide by HD, which is this piece, is equal to AD is this whole segment, divide by GD, which is this one. So maybe at this point, it's better to draw those figures separately if you don't really feel good about those yet. So I'm gonna draw those. Maybe I should have done this at the beginning, but still useful. So I'm gonna draw those two separately. So whenever you feel you are not getting stuff when two figures on the same picture, so you can actually split them to make a bit better looking, because you can see the corresponding sides easily in those cases. So this is D, this is G, and this was H, and then this is B, and this is E, and this is F. So what we know so far, we proved the two sides are proportional, right? So far we got FD, okay, so this guy divided by HD is this guy is equal to AD, so this one divided by GD. So two sides of two different triangles are proportional, which I hope it reminds you something, right? So that's two sides are proportional. But we don't know about the third sides yet, so we are gonna need something else. But what we can do more is basically, we know the angle D, and angle D is the same angle. If you look at the original picture right here, so angle D is the common angle. So which is why that will be our next step. So angle D is the same as angle D in both triangles. So this angle, let me label those. So the angle D, okay, so the angle D right here, the same as angle D right here, because that's the same angle. And then whenever you have a figure that is common in both like triangles, we call that is reflexive property. If you are wondering what that looks like, so just the same thing. So angle D is the same as angle D, or if I say a segment equal to itself, then that's also called reflexive property. So that's another thing to remember. And now we do know, like from the statement 7, two sides were proportional. And from statement A, we know one pair of angles, which is the angle in between those two proportional sides, are congruent. Okay, so this means congruent. So which is going to be enough for us to say these two triangles are similar by side angle side. So it says DEF. So DEF is going to be similar to DGH. So I'll go with that. DGH. And corresponding, okay, actually that was given. So let me. Yeah, so the DEF is triangle is similar to, this means similar to DGH, which is those two triangles are similar, because that is by side angle side. So let's see if we have that. Some people are choosing the side angle side congruence property, but that's not congruent. They are similar. So we have to choose similarity, which is one of the lower one on the options. Okay, so that's side angle side similarity property, because we proved two sides are proportional, and one angle that is in between those two proportional sides are congruent. So which is why that would be enough to say they are similar. And that's the statement. And as a result, if you have two figures are similar, then they have all three angles are congruent and all three sides are proportional. So, and then the last statement says right here, DFE, so DFE, which is the angle F right here, which corresponds to this guy, is H, so it has to be congruent. So that would be DHG, right? Okay, so be careful. This means angle. So this was a triangle. So DHG means the angle at this corner. And the reason why that was the case, because we proved in the previous statement, these two triangles are similar. If you have similar triangles, all the corresponding angles has to be congruent. It says corresponding angles of similar triangles are congruent. So that is the good reasoning. And that's the given already. And from here, we can say all three sides are proportional. Since we already know two sides were proportional, and then we proved that the triangles are similar, which means the third side, GH and EF, has to be parallel as well. And if you remember, that was actually what we were trying to prove. So it's HG and FE. So we can just say HG and FE are parallel. Why they are parallel? Because that's the third sides of the similar triangle. So corresponding like sides of the similar triangles are proportional. So we should get something like that. So let's see if we have, yeah, good reason. It says corresponding sides of the similar triangles are proportional. Since we proved these two triangles are similar by side angle side similarity property. So that means the third side and the third side should be proportional as well. And that is actually the last statement we can say. I hope that makes sense. So this was a nice kind of prose of the parallel lines. So it looks parallel, but we just show by some reasoning. Okay, so that's the answer. I'll see you in the next video.